Okay, guys. So, in this live tutorial, we'll be looking at a 2022 past paper science, which is paper 2 chemistry. Okay, the internal one, the one which is written in November. Okay, so guys, we're going to do this first question, or the question on uh, B5, okay, which is section B, question 5. Okay, so this question, guys, is coming from more concept, okay, and we really need to pay attention when answering such questions, okay, because sometimes they're really tricky, okay. So you really need to pay attention, think, analyze every information that is needed there. Okay, so guys, now to start with, so that's saying calcium nitrate decomposes on heating according to the equation. Okay, so we have our equation right here. So this is calcium nitrate. After it decomposes, what we're obtaining, or what is produced, is calcium oxide plus nitrate plus oxygen gas. Okay, that is what is produced. Okay, now when they say decomposes, it means decomposition means breaking down. Okay, so once this calcium nitrate is broken down, what will be produced is calcium oxide, nitrate, and oxygen gas. Okay, now the first question they're saying, copy the equation given and balance it. Okay, so what we just need to do as there is to balance the equation. Okay, so before balancing the equation, we need to check, is it balanced first? Okay, that's the first thing that you need to check, if it is balanced or not. Okay, so for us to check if it is balanced or not, we can use this simple method. Okay, we can use this simple method I'll illustrate here. Okay, so you can draw a cross like this, then this part, okay, this part, these are known as the reactants. Okay, these are known as the reactants. Then this, what is produced, is known as the products. Okay, so now on the reactant part this side, the number of atoms should be equal to the number of atoms on the product side. Okay, so we first need to check, okay, are they equal? Okay, that's the first thing you need to do. You need to check if the equation is balanced or not. So let's check. So we can say, we can put the reactants this side and the products this side. So the first element we're having is calcium. So calcium, you can see that here there's only one atom of calcium and one atom of calcium this side. So calcium is balanced like that. Okay, we're having calcium on the reactant part 1, and on the product part we're having only 1. Then we go to nitrogen. Nitrogen here, since this nitrate is in the brackets, we can have 1 here, which is for nitrogen. So 1 multiplied by the 2 which is outside here, which is 2. Okay, so this side nitrogen is 2, then this side nitrogen, it is just 1. So nitrogen is not balanced, something like that. Okay, so on the reactant part, we're having more nitrogen compared to what is produced. Then the other element we're having is oxygen. So oxygen here, inside the brackets here, we're having about 3 here. Okay, so 3 multiplied by the 2 outside there, which is 6. Okay, so on the reactant part, we're having 6 oxygen. Then on the product part this side, we're having about, we have 2 here plus 2 here, which is 4, plus 1 here. Okay, so 2 plus 2 plus 1, which is 5. Okay, so oxygen has also not been balanced, so it looks like that. Okay, so this side we're having 6 on the reactants, then on the products we're having 5. Now guys, listen, once you are balancing any equation, if in the equation there's hydrogen or oxygen, then balance these two at last. If you ever have hydrogen or oxygen balance them at last. So looking at the equation we're having there, we have oxygen there, so we'll balance oxygen at last. Okay, we're going to balance oxygen at last. So since I'm going to balance oxygen at last and calcium is balanced, so I just need to go where nitrogen is. And to balance nitrogen, if you look at on the reactant part, the number of nitrogen is more than on the reactant is more than the one which is on the products side. Okay, so what you need to go to do is go on the part where it is less. Okay, so the products are less. So if we put a 2 here, okay, if we put a 2 right here where it is nitrate, which means we're balancing nitrogen, or nitrogen. Okay, so nitrogen becomes balanced. Okay, which means it becomes a 2 here, nitrogen 2, and this side nitrogen is 2, so nitrogen becomes balanced. And one thing that you need to take note is that once you're putting these numbers here, they're just temporal numbers. You're trying them. Okay, you're trying them if the equation becomes balanced. So when I put a 2 here, nitrogen becomes balanced, but I'm affecting oxygen. Okay, then oxygen will be what? Oxygen, which means we're going to have 2 times 2, which is 4. The 2 that we're going to put here. So 2 times 2, 4, plus 2, 6, plus 1, 7. So oxygen becomes 7 now. Okay, then this side oxygen is still 6. So by putting a 2 here, we're affecting oxygen here. Okay, so for me to again try to increase on oxygen this side on the reactant part, I can put a 2 where calcium is this side on the reactant part. Once I put a 2 here, then which means again I'm affecting everything here, including calcium and nitrogen. Not only oxygen, but calcium and nitrogen. So calcium becomes a 2 this side. So even here where there's calcium here, we can put another 2. Once we put a 2 here, again we're affecting oxygen, which means we have more oxygen. Whereby when you say 2 times 1, which is 2 oxygen here, plus 4 oxygen, which will be here, 2 times this 2, so there's 4 here. So 4 plus 2, 4 plus 2, that is 6. Okay, 4 plus 2, that is 6, plus the 2 which is hydrogen gas this side. Okay, which is 8. So having 8, so it becomes imbalance again. So the thing that we need to do now here is remove the 2 which we had put here where it is nitrate here. We put a 4. Once we put a 4 here, then everything becomes balanced, and it looks like this now. Okay, that is how it will look. Okay, so we're going to have, if you check now, calcium, there's 2 here on the reactant part, 2 calcium here and 2 calcium here. Okay, then for nitrogen we have 1 times 2, which is 2, so nitrogen this side 2. Even this side, okay, nitrogen this side, sorry, take note, nitrogen this side is 4, because this 2 is affecting everything. Okay, take note, very important. Okay, so this 2 times 1, that is 2. 2 times 2, which is outside here, which is 4. So nitrogen this side is 4. On the reactant part, take note, on the reactant part, nitrogen is 4. Okay, because there's a 2 here in front of calcium. So 2 multiplied by the 1 which is inside here for nitrogen, which is 2. 2 times the 1 outside here, outside the brackets here, which is 4. So nitrogen is 4 this side. And if we go this side, nitrogen is 4 also here. So nitrogen has been balanced. Then for oxygen now. So oxygen, this 2 is also affecting oxygen. So 2 times 3, which is here, which is 6. 6 times 2, which is outside here, which is 12. So oxygen this side is 12. Okay, then on the product part this side, we can say 2 times 1, which is 2. So here we have oxygen 2 plus 2, which is here. Okay, then this 2 multiplied by the 4. So here we have 4 atoms of oxygen here, because this 4 is affecting the oxygen which is here. So 4 times 2, which is 8. 8 plus 2, 8 plus 2, which is 10. 10 plus 2 this side here, which is 12. So everything becomes balanced like that. Okay, So these are the important principles that you need to put into consideration once you're balancing equations. Okay, then now B, question B. For B, they're saying we calculate, okay, we calculate the relative formula mass of calcium nitrate. Okay, so calcium, take note, calcium nitrate, this is calcium nitrate here, this is the symbol, okay, the chemical symbol for calcium nitrate. Okay, calcium nitrate is made up of one atom of calcium, two atoms of nitrogen, and six atoms of oxygen. Two atoms of nitrogen, six atoms of oxygen, and one atom of calcium. Okay, that is what we find in calcium nitrate. Okay, so now when they say relative formula mass, okay, it is the symbol for relative formula mass is MR, also known as Mr. You can just call it Mr. Okay, and take note again, the relative formula mass is also known as the molar mass. Okay, it is also known as the molar mass. Okay, so when you say molar mass, relative formula mass, it is one and the same. Okay, so by finding the relative formula mass for nitrogen, so we can first write the equation for, or the formula for calcium nitrate. So that is calcium nitrate. Okay, that is our calcium nitrate. So for us to get the relative formula mass, you just multiply the number of atoms present there. Okay, the number, which is, like for example, oxygen will having 6, so 6 multiplied by its mass number. Okay, 6 multiplied by its mass number. So you can use arrowheads like this. So for oxygen, so oxygen, how many atoms are we having? Having about 6 of them. 3 multiplied by 2, which is 6. So we say 6 multiplied by the mass number. 6 multiplied by the mass number. Oxygen is atomic number 8. It is atomic number 8, and it has mass number 16. So 6 multiplied by 16, which is giving us 96. Okay, 6 multiplied by 16, that is 96. The nitrogen, we only have 2 atoms. We have 2 atoms there. Okay, 1 multiplied by 2, which is 2. So we have 2. So we say 2 multiplied by the mass number for nitrogen, which is 14. Okay, nitrogen is atomic number 7. Atomic number 7. Then it has mass number 14. So we say 7 multiplied by 2 multiplied by the mass number 14. Okay, 2 multiplied by the mass number 14, which is 28. Okay, something like that. So 2 multiplied by 14, which is the mass number, which is giving us 28. Then calcium. Okay, so calcium is atomic number 20. Calcium is atomic number 20. Then it has mass number 14. Okay, if you don't know what mass number is, mass number, this is the sum of protons and neutrons contained in the nucleus. Okay, so the total number, the sum, which is you just add the mass, the proton number and the neutron number, that gives you the mass number. So the mass number for calcium, is 40. So calcium, that we only having 1 calcium, so 1 multiplied by 40, which is still a 40. Okay, which is still 40, something like that. Okay, then after that, now we just add everything up. Okay, we just add everything. We add 96 plus 28 plus 40, which will give us about 164 grams per mole. Okay, that is how you find the molar mass, or the relative formula mass. That is 164 grams per mole. As simple as that. So in the next video, I'm doing now question C. Okay, question C. Thank you very much.